As we are aware about the electric flux, that is the number of electric field lines that are passing through an area. Here we have the magnetic flux. So the magnetic flux is defined as the number of magnetic field lines that are passing the area. Here we have this surface and we have the area vector of the surface that is normal to this surface, that is M, and these are the magnetic lines of force that are passing through this area. So theta is the angle between the normal to the surface and the magnetic field lines. We define phi, the magnetic flux, as B dot A. B dot A, where B is the intensity of the magnetic field and A is the area. We know that dot product is equal to BA cos of theta, where theta is the angle between the magnetic field lines and the area vector of this surface. Now we have, as it is the dot product, so flux or the magnetic flux is a scalar quantity. Now if the theta is equal to 0, if theta is equal to 0, that means the plane of the surface is perpendicular to the magnetic field lines, and the normal to the surface makes an angle of 0 degrees with the magnetic field lines. In that case, our phi is equal to BA cos of 0. Cos of 0 is equal to 1. So flux is maximum when the plane is perpendicular to the magnetic field lines, or the normal to the plane makes an angle of 0 degrees with the magnetic field. Now we have magnetic lines of force here, and we have the plane of surface like this. So the area vector makes an angle of 90 degrees with the magnetic field lines. So we have phi is equal to BA cos of 90 degrees. BA cos of 90 degrees. So phi is equal to 0. That means the number of field lines passing through this area is equal to 0. So flux is equal to 0. Here we have got maximum flux because all the magnetic lines of force or magnetic field lines are passing through this area. Talking about the units and dimensions of magnetic flux. Units and dimensions of phi. Units of phi are Weber, and we have that phi is equal to BA, taking theta is equal to 0. So Weber is equal to, the SI unit of magnetic induction is Tesla, and area has got meter square. So Weber is Tesla meter square. The CGS units of flux are Maxwell, and 1 Weber is equal to 10 raised to power 8 Maxwell. Talking of the dimensions, we have that the force is equal to BQV, so magnetic field is equal to F divided by QV. Now as phi is equal to B into A, we can have that flux is equal to F by QV into A. Taking the dimensions of the force, we have dimensions of force are MLT minus 2. Area has got dimensions of L square. Charge has got the dimensions of AT. As we know that current is charged by time, charge is current into time. Now this is velocity. Velocity has got the dimensions of LT minus 1. So we have ML3T minus 2 divided by A into L. So phi is equal to ML2T minus 2 divided by A. The dimensions of the phi are now ML2 T minus 2 A minus 1. These are the dimensions of magnetic flux. From the dimensional formula of phi ML2 T minus 2 A minus 1, we can have that the phi is equal to work done per unit current. And we have that current is charged by time, so we have it as work done per unit charge divided by time. So phi is work done per unit charge into time. We know that work done per unit charge is potential, and that has got the units of volt, and time has got the units of seconds. So we have that another units of phi are volt second. So the units of phi are Weber and the units of phi are volt second. This was possible when we had the dimensions of phi. Thank you.